Hello, everybody, and welcome back to my channel. Today, I have a very, very exciting guest for my uh, podcast episode, North Star with Bhavana Hindupur. And the person I have with me today is Donald Raab, someone I worked with at Goldman Sachs. I think he was my manager's manager at that time. I had the good fortune of almost starting my career in his team. So that really shaped the kind of programmer I became. Um, Don is a seasoned programmer who's been programming for more than 40 years. I think I'm not sure how many of those years is professionally, but he's definitely been programming for more than that much time. Don is a Java champion. Don has spoken at, I think, tens of conferences now around the world. Um, he is soon to be a published author, which we are going to talk about very soon. And Don also writes very regularly about programming, about Eclipse Collections. Okay, I haven't introduced Eclipse Collections yet, but I will in a minute. On Medium, which I will be linking under the video. Welcome, Don. It's so great to have you here.
So thank you so much, Bhavana. Really appreciate you inviting me to, I guess, do the talk with you today. It's been quite a while, so and thanks for all the shout outs. Yeah, it's been an exciting, I guess, 40 something years that I've been programming. Yeah, in terms of professionally, I think maybe it's like 33, 35, somewhere around there. So really started professionally as soon as I was out of high school. So started
That's
consulting
crazy.
while I was in college, but yeah. So thank you so much.
Amazing. Really, really excited to have you here. So, I actually want you to actually tell us about what Eclipse Collections is and what is your relationship with it. Let's start there.
Wow. So Eclipse Collections is an open source Java collections library. It's a library that was inspired from my background and experience as a Smalltalk programmer in the 90s. So I programmed professionally in the Smalltalk programming language, which a lot of people may not have heard of, and most people certainly haven't programmed in it. It's still around and alive, but it's very niche. But Smalltalk has had such an amazing impact on so many things that we take for granted today. And Eclipse Collections happens to be one of the things that it's actually had quite an impact on. So I was programming in Smalltalk. I was using, this amazingly powerful dynamic language that had an incredible collections hierarchy. And I got to, learn about different, APIs and behaviors. And when I moved to Java, programming professionally in the early 2000s, so really like 2000, 2001, started programming full time in Java, like
What
Java.
version was that?
So I started, I guess, professionally was probably JDK 3.
Wow. Okay.
Um, I had done some, I guess, training as early as JDK 1. I want to say 1.7. I'm not going to get the version numbers right at that early stage, but it was one
Right.
of the 1.1
Right.
numbers of Java, and it was like I started taking Java classes when I was and doing some, just teaching myself Java back in the late 90s while I was still programming in Smalltalk. It was really after 2000, 2001. And I recall it being Java 3. I would say, it started getting more serious as we hit Java 4. And Eclipse Collections actually started being developed in JDK 4. So,
That
and I,
early.
yeah, so I started creating it, and I have some in my blogs. I tell the creation myth or story of Eclipse Collections, which goes all the way back to 2004. So this is now the 20th year that I've been working on this library. That's it's been out in open source for 12 years, and has been at the Eclipse Foundation, which is if folks haven't heard of it, similar to like the Apache Software Foundation, where it's a foundation that has projects. One of its obviously most well-known projects is the Eclipse IDE. But Eclipse Collections is a project at the foundation, and we moved it there from Goldman Sachs, where it was originally developed, to the Eclipse Foundation in 2015. So it's, I guess, like almost like 10 years it's been at the foundation. So yeah, so it's really, and I guess we'll talk about it later in the book, but after 20 years of working on this library, and I've written tons of blogs, like the I just passed my 7-year blogging mark. So I've been
Wow.
blogging publicly on Medium for 7 years. I think I'm up to like 211 blogs now. So it's, roughly like 30 blogs per year I've been writing. And I know you're, actively blogging now, which I go out and read your blogs. And you've got quite a few out there now, which is great. So I hope, you keep at the writing. I encourage
Yeah,
everybody I encounter, write stuff down. Like, so much of what we know and experience won't survive because we haven't, bothered to take the time to write it down. So take that time.
absolutely. There's so many interesting points you touched upon there. So you started working with Java early on, and people who are programming in Java right now might not understand the pain that came with writing all of those for loops. Um, and did you program with? Yeah, of course you were with Java before generics as well.
Yeah,
So
so Eclipse Collections as a collections library too was pre-generics, and we had to do a
gosh,
migration of a collections library to generics, which obviously the JDK had to do as well with the Java Collections framework that's built into the language. But yeah, we had to do it, and we have a lot more APIs that needed to be migrated. Um,
right.
so it's a much richer API on our collections. So there were just tons and tons of work that I felt like the migration to Java 5, even after we started compiling and releasing on it, took forever. It was like years of just, oh, we got more generic stuff to clean up and fix. So um, yeah, it was interesting. So
I can
yeah, like
imagine.
pre-generics, yeah, it's like I don't cast anymore really that much in Java. Occasionally, yeah, you can't get away from it, and definitely like in the collection space, we wind up having to do it in some places, but usually it's like buried, behind some API. It's never, exposed to some client. So yeah.
Yeah, I can myself remember the transition from having to cast a lot of things to, I think when I started programming in Java, it was just pre-generics, so it was just as generics were being introduced. So I remember doing some very painful casting at that point, and then reading about generics and realizing that it's not perfect now either, but it's better.
Yeah, well, it's funny too because like when developers learn generics, and I still occasionally have the problem looking at code and say like, what is this super, and
Yeah.
extends, question marks, and yeah, so generics they're really powerful, but they can be mind-numbing to read, especially as they like get nested in other things. So, but yeah.
Yeah, yeah, very interesting. So, at what point while writing code for your business in your job did you realize that I need to make a framework? This is too painful. Did you start, was it a gradual process where you found yourself writing more and more utilities around your for loops, or was it like a 0 to 1 moment where you realized that you're going to create this library and it's going to be open sourced?
Well, there were moments where things happened and it was not planned. Um, I basically, and I have there's a thing I like to say all the time, which is like, you ask me a question and I'll usually respond, there's a blog for that. Um,
Yeah,
so
I'm aware.
there is a blog about the thing that really began Eclipse Collections, which was I was working on a project, and it was in the 32-bit Java space. Everybody remember 32-bit programming? when you only had access to like,
No.
like I think probably like 1.4 gigs on Windows, and if you used Sun Solaris, everybody remembers Sun Solaris? Like you could access up to 4 gigs on a Sun Solaris box, but like imagine that you needed more memory than 4 gigs. And yeah, I had this problem where I had an application I took over, and it was basically an application that cached all data and um, ran processes against the data and actually then created in-memory data structures where there were millions of objects. And what happened was like it just wouldn't fit in the 32-bit memory space. And it was I tell the analogy, I'll be nicer about saying it's trying to, the way I describe it is like it's trying to fit like 10 pounds of stuff in a 5-pound bag.
Yeah.
And basically I think in total, I calculated at the time, I needed about 7 gigs of memory just to like load the stuff and run the calculations, the minimum number of calculations that our users wanted to run. And I'm like, well, I got 4 gigs. I need seven. What do I do? Right. So there was a moment where like I had to um, dive in and figure out what can I do here. And it's like, it was a architecture, that I had inherited. So I was looking and saying, okay, well, there's the easy thing, which is, oh, I'll just restart this and use, framework XYZ and everything will be lovely and, it'll be my brand new architecture. It's
Right.
like the solution to every problem. Let's just rewrite it. But I looked at the problem and said, how can I how can I actually make this thing work, right? And
Mhm.
so I started having to dig in and understand like, what are the problems that this thing faces? Like what takes the memory? And at the time,
Sure.
I had never really dug into measuring memory in
Yeah.
anything. Now, it was weird too, because like when I started programming professionally, in the, I think 1989 was probably the year. Like, I programmed in DOS, and we had access to 640K. So I was used to memory constrained environments,
Sure.
but I never measured memory. It's like I just, of things I just used them, memory was there. If I ran out of memory, then I would have had a problem and I'd have to address it, right? But most stuff,
Mhm.
like we had techniques for like working in these small memory spaces. But like when you're in the, I got 4 gigs of memory and I'm loading all this stuff in it and it doesn't fit. It's like I got to figure out like what is taking up the memory. And you start to have to understand how memory is laid out in Java and actually what the cost of objects head. And you learn about object headers and you learn about the cost of primitives and arrays and collections. And it wound up being that as I was investigating where the memory was going, and I was using this tool in Java. It's still around. It's a command line tool. It's called JMap. And what you can do is like
JMap.
I think it's like jmap-histo or something, and give it a process ID. And basically, it'll give a layout of all the objects on your heap, ordered
Yeah.
by like what's taking up the most memory. So immediately, like you'll see things like string and arrays like up at the top, but you have no
Right.
idea like where those things are coming from. So I was like, I got a gazillion arrays. Like, where are they coming from? And you start going down the list of things taking memory, and I'm like, okay, well I've got a lot of array lists, and I've got hash sets, and I've got maps, but I see these things, and I know that okay, ArrayList has arrays, but I don't know anything about the makeup of the data in those arrays. I don't know how big they are, right? So all I see is like a number of instances of array, this much memory is taken up. So then I had to keep digging into the code itself and say like, where are these things coming from? Like,
Mhm.
what creates array lists? What holds on to them? And what I found and discovered through just once again beating my head against the wall, trying to reason about what was happening in the app, and I would say like I'm using like rocks, paper, sticks to solve these problems because we had limited tools
Yeah.
back in the day. So I was able to discover that during the process of calculations, that a graph was being created where each node in the graph had a list of parents and a list of children. And
Right.
what you would do is like you'd start from, let's say, some financial positions that were loaded in a cache, and you do a whole bunch of calculations that take this position through a bunch of calculations, and you wind up with each node as it's going along, so you can see like how did this position wind up with, let's say, a charge at the end. And you
Mm-hmm.
can look at the charges and get back to the positions, and you look at the positions and see how they wind up in charges, right? So,
Mm-hmm.
um, but each node has an array list. Now, what happened back in the day, if anybody remembers the old version of array list, when you create an array list with a default size, it creates a backing array of size 10.
Right.
So most of the nodes in the graph would have, let's say, one parent, and most
Mm-hmm.
of the time they had, two children. Or other cases where they might have more. But basically, like if you've got an array to hold 10 things, but you only need one thing or
Right.
two things, right? You're wasting a lot of memory for space that you're not using. So what I had, decided to come up with is like, well, let me create my own memory efficient lists where they don't have backing arrays. Let me get rid of the array altogether, because if I need a list of one thing, let me have a list that has one pointer to an object. And if I need a list of two things, then let me have a list with two pointers. Now, when you use structures like this, they weren't, it was interesting because at the time they weren't immutable.
Right.
If they were, you'd be separate from them. I needed them to actually be mutable because
Mm-hmm.
there was code that relied on being able to sort these lists. So the lists were not growable. They were fixed size, but they needed to be able to be sorted. So they had to
I
be able to
see.
respond
Interesting.
to, the set operation. So it's implementing the list API. It needs to be sorted, which means I have to have, the ability to set elements in there. Right now, setting when you've got two pointers, and as long as they're not final, it's easy enough. Just call set. If you know you're at
Yeah.
index 0, change that pointer. If you're at index
Yeah.
1, change that pointer, so on and so forth. So it was just at some stage, like I think at the time I went up to like size 6 for lists. What I found is like there was memory benefits up to size 6. After that, it just started to drop off. So I was like, I don't need 79. So I only built what I needed. But I did the same thing. I wound up, saving memory too for like sets and maps, and through just I would say a whole ton of investigation, whatever. We got the app to actually run in under 4 gigs, and we're able to, I think, if I'm not mistaken, like run at least 2 calculations. But what was interesting was like around the same time, 64-bit JVMs became a reality, and we could actually
Mm-hmm.
start leveraging those. So I believe we leveraged 64-bit with Java 4. I think that was when it was first released,
I see.
and
Okay.
then actually, moved to Java 5. But it was interesting because when you moved from 32-bit to 64-bit, initially, like your size of pointers moved from, like, say, you got 32-bit references to 64-bit, so it was like you were moving from like 4 bytes per reference to like 8 bytes per reference. So interesting things happen in terms of the total amount of memory now that you're using suddenly increases when you move to 64-bit.
Right. Right.
And years later, and we would experiment and use this stuff very early on. Java introduced this concept of compressed OOPs,
Mm-hmm.
which most developers now, if they're working in modern Java, they never probably set any of these things. They're just automatically set for you. So
Right.
if you're under a 32 gig heap, you kind of like get the benefit of, they have this cool magic which allows you to use 32-bit references. I think between
I see.
32 and 60, there's some step function to like where, it uses 32-bit references, but you might have a slightly higher cost somewhere else. I forget exactly where. It's been quite a while since I looked. But yeah, past 60 gig, you're, true 64-bit. So you get a real hit there. So what we found is like a sweet spot for like large in-memory caches and whatnot was less than 60 gig, because then we were at least able to get, the benefit of some hardware savings. Beyond that, it's like now you have to have really, really big hardware. So, but that
Right.
was a long, I guess, story of like that's where Eclipse Collection started. But at the same time, I was doing that. I started, as you said, looking at, I'm dealing with collections everywhere, and I get tired
Mm-hmm.
of writing the same for loops over and over again. And once again, I'm coming from Smalltalk where like, everything is beautiful all the time. And, I've got these beautiful collections with all these wonderful behaviors. I'm like, here I am writing for loops. And so there's a blog for this as well, where I talk
Sure.
about, and it's funny because like, folks programming since maybe just Java 8 have never experienced a Java without lambdas, but Java didn't always have lambdas.
Yeah.
And it was Java 8 was released in 2014, so Java's only had concise lambda expressions for 10 years. Before that, we had to use these god awful, ugly things called anonymous inner
Anonymous
classes.
inner classes. Yeah.
Yeah, it's funny because I mean you could still use those. In fact, like some of our documentation in Eclipse Collection still has examples where you can use anonymous inner classes, but I'm tempted some days to just rip that out of all our docs because developers today are probably looking at it going, "What's that? And why does Eclipse Collections make me write that?" What's an us? What's an us?
Yeah.
But yeah, so I
Yeah.
started then once again. I had these memory savings techniques. We then started building utilities for getting rid of for loops and introducing functional APIs for like filtering and transforming and all of these things. So, and then it
Yeah.
just started. It kept evolving. It kind of like you know well, I liked using it, and I would teach developers who I worked with how to use it, as you know, and folks started to like it, even with the anonymous inner classes. Somehow I was able to magically get folks to see some bright future where they wouldn't have to write this ugly bit of structural code in between this lovely piece of code that does all this work for me, right?
Yeah.
So
It is very interesting when you said that the start of Eclipse Collections was memory savings, because when I started using Eclipse Collections and when I started working on it, I think the best part of it was for me to avoid the for loops, just to make my code more readable. I guess at that point, I didn't have the business need to be so particular about how much memory I was using. It was more about making my code more readable, being more productive, being able to write more code per unit of time, etc. But it's so many things, isn't it? You have performance enhanced collections, you have memory saving collections, you have lazy and eager collections. There's parallel iteration versus serial. There's just so many angles to Eclipse Collections. And have you ever been able to explain all of Eclipse Collections to anyone? Have you ever done a session where you've done, the
well,
top
I can't
100
explain it all.
features?
It's hundreds of blogs I've done it.
Yeah.
And it's funny because like some of my blogs focus on like different aspects, but it's interesting because I did give a talk at Java 1. I want to say it was 2017, maybe it was 2017 or 2018. I forget exactly, but it was about the evolution of Eclipse Collections, and I
Right.
had a slide that I used to, can I share my screen? Let me see if I can find it real quick. So I
You
had
can
this.
either share your screen or you can talk about it, and you can send the image to me later and I can put it in the video, like as you're speaking about it.
Yeah, um, so what I did was I had this slide, and of course I'm not going to be able to find it. You know what? Oh wait, no, there it is. So share my screen, right? Can you see that? Let's see if I can make this bigger in any way. Interesting. Command plus. Oh, there we go. Okay. I'll zoom in a bit. So to answer your question, this slide actually tells the entire story of Eclipse Collections, but I can't.
Up until 2017.
Yeah, up until yeah. But it was funny because like you can see what I just told you, right? It started out with
Yeah.
small efficient collections in 2004,
Yeah.
right? And let me just make that a little bigger. And then, the symmetric protocol. So those are like the rich APIs I talked about to get rid of for loops and whatnot, right?
Yeah.
But then we started introducing our own types. You mentioned parallelism. We did parallelism back in 2005, and that was
Oh,
before the
wow.
fork join framework was even in Java 7. So
Yeah.
so I was actually using initially the fork join library when it was part of this other library called from Doug Lee at the University of Oswego. Because when in Java 5, we got Java util concurrent, and that was actually a lot of the stuff that
The
Doug
executor
Lee had
service.
built out, at university with others. So yeah, so you got things like concurrent hash map and all these things. But like when Java
Right.
5 came out with Java util concurrent, they didn't move the fork join library in initially. It came in Java 7. We
Yeah.
did get executors, so executors were new, and it was interesting because like there was a whole bunch of work that I went through where initially I used the original version of the fork join library from the Oswego library, and then actually we migrated our parallelism to executors. And then
I see. Oh,
fork join
wow.
came out
Okay.
later, and we then provided a fork join implementation. But what's interesting is like um, the executor approach, because we leveraged it so early, and since we had experience doing parallelism for quite a long time, and we happened to operate in the space where because we were loading lots of stuff into memory,
Hmm.
like we'd load millions of objects in memory. I think back in 2005, probably the biggest collection we ever loaded in memory was like 100 million trades, right? So at the
Wow.
time was like, astronomical, and maybe like the heap was like 100 gigs, right? So like no one had heard of these slice things back in 2005, but we were dealing with them, and so we had, when you have everything in memory, and okay, that seems fast, but like when you start doing processing, and if you're doing stuff where it's user-facing time to do the processing,
Mhm.
right? Because you're doing it ad hoc as they need. It's like, well, I've got these like 12 cores on this box, and I got this stuff I'm going through, and it's taking seconds. Can I cut that down to like, either under a second or even milliseconds by leveraging the cores? And we had really great experience taking our symmetric protocols and functional APIs and creating parallel versions of them. So, and it was interesting because like our parallelism was different. We didn't try and come up with a generic parallel framework. We basically said like, right, I want to leverage cores to do in-memory, data, um, you know, processing. And it's like, how
Aggregation.
can I do
Yeah.
that? So it's like we didn't come up with a lazy parallel framework. We just created eager operations. So we actually started with
Right.
eager parallelism, and I don't see anyone else that actually has eager parallelism. And we just found it was like extremely useful because like if you start having to tune and you really want performance, a lot of times what you just need is like a parallel for each, and then
Hmm.
you figure out what's optimal for like the type of processing you need, right? Does it make sense to use concurrent data structures or not? It's like, does it make sense to fork things off and then merge them, and where are you going to incur the most costs? So a lot has to do with like the makeup of your data and the number of operations you do.
Hmm.
So we had a lot of experience like leveraging stuff like this. It was years later we introduced our own parallel lazy API, and when we did
Hmm.
that, we said, so if anybody, for folks that use Java streams, you can say like list.stream or list.parallel stream, and you just get a
Yeah.
parallel version. And underneath the parallel version will leverage the fork join library, and it sets up a static fork join pool for you. What we decided when we came up with our lazy API was like, based on our experience doing eager parallelism, we said
Hmm.
most of the times developers need to understand what they're doing, and really what they want is like the ability to tweak and tune things, right? So maybe they want to have their own, pool of threads and whatnot, and they want to actually manage that. So we basically made it so that when you call our lazy API, you have to pass in an executor.
Right.
You determine how this thing is going to operate. Now it's interesting because like that design decision yields some interesting things, because here we are now, the current long-term supported release of Java is 2021,
Right.
and it has the Project Loom built in, so it's got
Hmm.
virtual threads
Thread.
built into it, and everybody's talking about it. It's funny because like what you can do with virtual threads is you can create an executors.new virtual thread something, and that'll give you the ability to start using virtual threads, and like you can actually use this with Eclipse collections. And it may not be
Right.
that you want data level parallelism. You may actually just want to take a bunch of things, and maybe they're doing IO, and you want
Hmm.
to do IO in parallel, but you want to reduce the amount of code you have to write to
Wait.
do that. So you can have, let's say, a small list of stuff that goes off and does things in parallel, and you can just do like list there as parallel, pass into virtual thread executor, and all of a sudden your code gets somewhat simpler. You can focus on the problems you have, and you're able to then leverage the new executors, right? Whereas with parallel stream, you still get the same fork join pool, static and memory. And they may tweak that behind the scenes to give you something different, or you can try and there are strategies people have come up with that you can, create your own fork join pool to do work and whatnot, right? So
But it's not as easy as just creating an executor and
yeah,
passing
and
it
once
in.
again, for us, it was like we started from eager. We had lots of specific use cases we were solving. When we moved to lazy, we just our experience said that developers need to have the bells, knobs, and whistles. In fact, what we wound up with in the eager space, we wound up with like a ton of overloaded methods because developers wanted to like tweak this parameter or
Hmm.
this parameter for like parallelism. I was like, oh, let me give them another API to do that, right? And it's like we
Right,
felt it was much better. Like, let's give them two things they can control. You get the
right.
executor and you get a batch size. And
Hmm.
those are the things most of the time they want to control. It's like you determine when parallelism happens, right?
Hmm.
So if you want a batch size of 2 and you want parallelism to happen, every 2 things, then fine, go ahead, do that, right?
Right.
um,
You probably shouldn't, but
well, it's funny because like there are actually specific use cases that actually work well with that, right? But that was what our experience said is like give them executor, give them batch size, and let them have at it. So it makes the API more painful initially to use, but my experience with that is like I believe that's a better decision because you should not make it easy for developers to get parallelism. Because if you make it easy, my feeling is like developers will often sprinkle parallelism in their code without
mhm,
measuring anything and actually knowing
right,
whether it's benefiting. And what they may actually be doing is causing their app to go slower and use more
right,
resources, right? And it's like um, just because they felt like, hey, look, parallel, good, sprinkle magic, right? So at least if you
right,
make it harder, like, okay, they had to think about it before they used it.
right.
So it's not much harder, but it's hard enough where like it's not just a flick a switch with a method name from stream to parallel stream and it's done.
Wow. Yeah, I think I was around the time when this specific lazy parallel decision was being made, and I remember all of these discussions around it. It was a hot topic.
Yeah, it's funny because that space too. Obviously, Eclipse Collections, one of its great things is it integrates with, the JDK types on the
Yeah,
mutable side, right? And we have both
yeah,
mutable and immutable collections, and both actually integrate with Stream as well. So the nice thing is like you can use parallel Stream if you want. So we get the benefit of everything in the JDK plus everything else that we offer. So the lazy um, the parallel lazy is interesting because like that's kind of like I view that as like a perpetual work in progress. Like some of that's
right,
implemented, but it's not fully built out. We only built what we found useful. So there's
right.
lots of opportunity for anybody who wants to experience
Contribute.
what it's like to develop parallel, collections to help build out that space. Because and we've talked about extending beyond just, let's say, lazy parallel, where um, I guess we do have this on lazy, on the parallel side. We have things like a whole hierarchy of like, there's like parallel list iterable, there's parallel bag iterable, but some of these things won't be fully built out. It may actually wind up executing
Right,
serial code.
right.
But I'm thinking as well, like one of the things we've also talked about is for our lazy, so we have a thing called lazy iterable, which is kind of the equivalent of stream in Java.
Hmm.
The
Hmm.
difference being that you can actually reuse a lazy iterable. So it
Right.
doesn't like the first time you use a stream, you
It
can't
doesn't
use it
just
again.
die.
You got to create a
Yeah,
new one. So
yeah.
lazy iterable, you can use it over and over again. So that's kind of interesting. But what we've talked about is like, at some stage maybe building out support for like lazy lists and lazy sets and lazy maps. Sounds like that's a ton of work though. So,
Yeah.
maybe when I retire and I'm bored, um, I could
Yeah,
do
and
that.
also it's cool that you stuck with what had a business need and spent most of your energy around that. I think that the fast list is am I getting it wrong? It's been a while since I've
Well, that is
used.
the list implementation. So
Yeah, so the fast list is probably the most used Eclipse Collections collection. I
yeah,
don't
it's
know if you
interesting.
can measure.
It depends on, well, it's funny because what happens now, and this is part of the evolution if you look on the slide, right? It's, you see where we have, do I have factories on here somewhere? Now, factories, I guess, came later. So it used to be that you would go to our collection types like fast list or unified set and unified map to create them. And we later added factories. So we have factories like lists, sets, and
Yep.
maps. So most developers now who learn Eclipse Collections never learn about the underlying implementation names. So they'll
Implementation.
never see those. They'll have like the
Interesting.
factory class, which says list.mutable.empty. And that happens to give
Right.
them a fast list. Or you can say list.immutable.empty, and that'll give you an immutable, or actually, that'll give you an immutable empty list. Because
Right.
once it's immutable, it can't grow. I have a single one in the JVM. You never have to create more. But yeah, so going through the factories, most people don't even see fast list anymore. So I would say it
Right.
was much more well known, when we were developing initially, because people had to know the class existed. But yeah, nowadays I never see fast list in any code I write. um,
That's really, really cool.
yeah,
Um,
so
yeah. So,
I'm gonna close
when you
this.
would,
Okay.
yeah, yeah,
Okay.
sounds good. Thank you. So at some point when you were doing all of this, um, maybe before or after Eclipse Collections was open sourced, which was initially called JS Collections, etc. So at what point did you start engaging with the Java community, and how has the journey been?
That's a great question. So I started engaging with the Java community, and I honestly wish I had done it much sooner. That was like, if
Mm,
I had to look back and say, like, what was the one thing I regret? It's like not engaging publicly. So first, I did my first public talk was in 2010 at GIDS out in Bangalore. And
No, that was when I was there as well.
No, 2012 was the next one I did,
Right.
which is I
Okay.
think when you were there.
Yeah.
But I did a talk at GIDS before GS Collections was open source, and it was about Caramel, which was the internal name for the library. And
Right.
that was the first time I had ever given a public talk.
Right.
And it was uh it was an amazing experience, and I've since done many more. I went back to GIDS in 2012 and presented there, and that was cool because that was in the big room, like 500
Yeah.
people. And I remember at the time, and I was like in awe of what was going on. Here is like maybe my third public talk, and Venkat Subramaniam was actually in the audience, right? And
Yeah.
I remember actually having to give him 2 USB drives because he asked 2 good questions. um,
I think the
um,
second one was just a joke.
I know it was. I was trying to give him a pass, but okay.
Yeah.
It was a good joke, so he got 2 USB drives out of it.
Good.
But yeah, it was kind of that was an amazing experience. That was the largest public audience I had ever presented to. But being somewhat senior, in banks, I gave internal
Hmm.
presentations to probably similar sized crowds, right? So
Yeah.
I had done, speaking, just not external. It was all internal. And obviously external is, a lot more on the
Yeah.
line.
Yeah.
People, get very nervous about, how you're going to come across, and, everything on the internet's forever, right? So,
Yeah.
but yeah, it was, you know, interesting. So getting back to when did I get involved in Java is really around 2011.
Hmm.
So there was a Java specification request called, acronym
Yeah.
JSR, and the
Hmm.
number was, I think, 335. Um, and JSR 335 was the specification request that got lambdas and streams into the Java language.
Mm.
So I was invited to, and I joined the expert group, and it was being led by Brian Getz, who's the Oracle Java language architect since probably around 2009, 2010, and still is today.
How
So
did they
he was,
find you?
huh?
How did they find you?
Because I was loud and obnoxious, and kept reaching out to whoever I could at Oracle whenever I could have a conversation, and said, "We need lambdas, we need lambdas." And it's
Yeah.
like
Okay.
I talked to several different over the years, like several different. I wound up in phone calls, for different purposes, talking about because we were working in the large Java space. Like I have phone calls and say, like, whoever was the Oracle Java language architect at the time said, we need lambdas, right? Brian was really, intent, I think, on getting lambdas in the language, and said, like, hey, here's someone at a user, customer
Mm.
that uses Java and has experience leveraging large, caches, has, parallelism, has all these cool things. And it was like, be maybe useful to have him on the expert group along with all these other industry luminaries. So I was like, this random guy from Goldman Sachs, and here were like, Brian Getz and Doug Lee and Josh Block and all these folks that like I have all their books and I've tried to get them all signed. Um, but I'm there, okay, I know something about lambdas, right? And it's really, I would say, the body of work that I had done in Caramel at the time, which when I joined the expert group, and I was actually giving feedback on, because initially there was discussions about what's the syntax of lambdas going to look like, right?
Mhm.
And arguments and debates about what that would look like, right? And then the underlying implementations and how it was going to be delivered. And I think it was quite amazing that what was arrived at was something that was took the language forward, but leveraged what was already there, right? So you could, because they used what are called nominal types, you have to have a type for a lambda,
Yeah.
like you have to
Yeah.
function or, runnable or, comparator,
Mhm.
which meant lambdas could work with existing abstract method types like
Mhm.
runnable and, comparator,
What we
but
call
could,
functional interfaces.
yeah, so they're called functional interfaces now.
Mm.
So, but it was nice because we had functional interfaces in Eclipse Collections. So what happened when lambdas came out, like they just worked magically
Yeah.
with Eclipse Collections. So even though like we, built our library some stage on, well, all the previous versions of Java, like when we were compiling still in like, Java 7, people could take the library and just use lambdas with Eclipse Collections and they just worked. Even though we didn't use lambdas in the library, they just worked with it, which was incredible. So anyways, being on the expert group was like really, I would say, the first time I was interacting with like the, really in some ways like these just amazing experts in the Java space. And my interactions were public. I was like emailing to the expert group, and every email that we wrote was archived publicly. It's out on the
Mm.
internet for
Nice.
folks to go look at. And I've written stories about this experience. There were
Mhm.
things as a result that would happen years later where I would do some testing with like early versions of Java 8 before it was released, and I found performance issues with Eclipse collections. And it turns out like there was something I found that we and former colleague of ours, Hiroshi, got to work on that with a developer who was working in the OpenJDK core team and basically developed this thing called random access splitterator,
Yeah.
which are for
I remember
lists
that.
that weren't in the JDK, didn't have their own splitterators, may have been built before Java 8 was available to them, would get a better version of splitterator. And it really, the problem I found was in parallelism. I was trying to use parallel stream and measure performance.
Mhm.
What I was finding is like if I used parallel stream with fastlist, like performance was actually worse than the serial stream. And I'm like, what's going on here? And dug around and like figured out. And then once again, there's a blog about this, like what it was I actually discovered. And I linked to some of the original discussions. And really, it's like the way I described in the blog. What I recommend to people is like if you see something, say something,
Yeah.
then test it and prove it, and then do something, right? It's like, and that's what we did with this. Like I saw this thing, I reported it, I wrote performance benchmarks. Now at the time, I didn't have a good performance benchmark framework to use, so I had to just use my own thing. But the numbers were so egregious that it didn't matter how good my benchmark framework was, right? It's like you can
Yeah.
see it's like an order of magnitude slower,
Yeah.
right? Or some multiple slower, let's say. But yeah, so that was cool. I wish, once again, it took me, that was like 2011, I joined the expert group. And
Mhm.
what was awesome about that, I was learning, I was contributing, I was participating, like I was getting to have conversations with folks about like the evolution of language. And then like 3 years later, Java 8 comes out, right? So it's like all of this work that we did for years, finally came to fruition. So while I was waiting for lambdas,
Hmm.
for 10 years since, the initial creation of Eclipse Collection in 2004. It was really like 3 years where I was actively involved in trying to help, get the work out there and ironed out so it could be included in the language. And I don't know, it's an amazing feeling to be part of that. And what I found after that is like that just changed my career completely. Um,
Right.
that experience of, wow, the stuff I do and I contribute to can have an impact way beyond just the single application space that I'm working on. Now, I
Hmm.
had seen that, inside of Coleman as well, like when I was developing reusable libraries and people could see the benefit, but I was like, it's like this small space. When you see that like something you did winds up in the JDK
Hmm.
or that you helped, usher in there, it's like there are, I mean, the estimates are between 9 to 12 million Java developers, right? So it's like these things impact these developers every single day, and they just use, this stuff day in and day out, and it's like used millions of developers and, billions of devices, and it's just amazing to think like this far-reaching impact that you can have. And the key thing is to just get out there and participate and do something,
Yeah.
and become part of the community. And it was years later, like, so joining the expert group in 2011, I didn't start blogging publicly until 2017.
Right.
What was I thinking, right? So, and now it's funny because I blogged, you might recall, like internally,
Hmm.
quite a bit. So, but making that leap externally was then, I would say, the next major change in my career. Is like all of a sudden, like all these conversations that no one will know about that, maybe you and I had when we were working on primitive collections and Eclipse collections and Goldman Sachs way back in the day, or that I would have with other developers about how to leverage Caramel before it was GS collections. Like those conversations don't exist anymore, right?
Right.
They're at a point in time with just one person. But the blogs actually, they sit out there. People can discover them and you can share them, right? So, and when you ask me a question and it would require like a 3 hour answer, I can say there's a blog for that, right? And it's like,
Yeah.
take your time if you want to read about it, but like I don't have to start from square one and explain the entire universe of stuff that I've done over this, 40 something years, right? So, and actually, there is a blog that you've seen as well I wrote called The Joy of Programming, where I
Yep.
tried to summarize what it is that brings joy, to me, of coding and how, um, you know, meeting my heroes. I have a ton of like programming heroes. I have like this deck of cards of like all my programming heroes, and I try and get all their. No, I'm just joking. But it's funny because like I do tell the
It's
story
very
of one of
believable.
it is. I did. Could you please take this shot with me so I can get you on my deck of cards? You'll be the 10 of diamonds. But yeah, so in this blog, I describe at the time what was 40 years. And, now I'm up to like 42 or 43 that I've been programming. I've been programming since I was 11,
Mm.
right? And there's just something for me about this joy of like, I'm creating something inside of this machine and getting it to do things, like do my bidding. And it's like just this amazing feel of creativity. Now, it's funny because like, um, I was never really like particularly interested in like math. So it's not like the
Mm.
the math aspects of computing. It's really like I was always more of a writer.
Interesting.
So I wrote a lot of poetry in high school. Bunch of it got published in my high school literary magazine. I've since put some scarily out on Medium, so you can read poems I wrote when I was a teenager. Going through teenage angst. Um,
I will try and find this.
Yeah, that's funny because like thankfully it's the published stuff that was somewhat decent, I guess, for a high school literary magazine. But it's kind of interesting, and I've well blogged about this as well. Encouraging folks to. I think one of the biggest problems developers or anyone has about writing a blog publicly is like there's some amount of just like fear they've got to overcome, right? It's like and it's like fear of being liked or what it is, right? It's like fear of being
Yeah.
a complete you know failure. It's like, and my advice to folks is like, get over that, right? Because like, you know, in 100 years, no one is going to remember the, blog that you wrote that like was a, complete and utter failure. But you know what? Maybe that like that blog that you wrote that was like inspiration or whatnot will actually impact folks for, years, and who knows, winds up being part of some collection of stuff that, when aliens come down to our planet and try and figure out what it was we did to ourselves, like, oh, look at all these cool blogs they wrote about what was going on. I don't know. Who's to say what happens to this stuff in 100 years, right? But
Uh,
um,
But
uh,
but you definitely improve as a writer,
oh
um,
yeah. So
as you're writing those many blogs.
yeah, and it's funny because like I look at like my early blogs, I'm like, oh wow, I was like a horrible, horrible writer. And it's interesting. What I find over time was like my early blogs are very sanitized in terms of my writing, and I can
Mm,
do this sometimes. And I think probably because I, worked in financial services firms that were highly regulated, and anything that we write, we got to be, careful about. So
yeah,
it's like, um, so I find that like it's my later blogs, and in some ways, this is going to sound weird. I think the pandemic was healthy for my blogging style.
yeah, yeah, yeah. A lot of creators say that.
And I started injecting more of personal stories in the blogs I
Mm,
wrote. And yeah, it's like I overcame this fear of, I don't know, sharing too much. Like I don't share everything, right? It's like, here's my social security number, here's my, credit card numbers, have fun. But I do share more personal stories. And what I found is that like, amazingly, that's the stuff people love to read.
yeah.
They don't want the sanitized information that really
Oh,
starts to read like, a reference guide to stuff, right? It's like, okay, put
yeah.
that in like your markdown file in your repo and I'll read that later if I need to, right? It's like
Right.
people want stories, right?
Yeah.
Um, so I found that, I try and tell more stories.
Nice.
And
So did
what I find too is
did
like,
you?
and this is one thing I explain to people, like, I think one of the fears that people have is like that they don't have any good stories to tell, which is a complete fallacy. You have so
Yeah.
many good stories to tell,
Hmm.
right? And it's like, you probably have to think about them. Once again, it's like if you can overcome that initial fear, it's like everybody has amazing stories. Okay, and
Yeah.
it doesn't matter that your story is or isn't as amazing as that other person's story. It's like, wow, I was not part of that cool thing that they did. It's like, it doesn't matter. Like you're doing cool stuff, and I want to read your blog, whatever it is, spend time, and I want to be inspired to write about stuff and hear stories. Because like, I hate to be the only one out there, writing, and people are having to read my stories, and I'm having to read my own stories for entertainment. I want to read other people's stories. But anyways, sorry.
Yeah. No. No. Of course. Um, I think that a lot of this um, coming up with stories, etc. It improves your writing, no matter what subject you're writing about, because you write about programming, and that doesn't necessarily have to do with stories, but it somehow makes it more easy to take in, and it reaches more people that way.
Well, it's funny because like that aspect is what I look at coding that brings me so much of the joy. I used to love showing my manager, whoever it was at the time, like the line of code that I wrote today. And look how amazing this code reads. Like, doesn't it read just like English, right? And it's like,
Yeah,
it tells you exactly what it does without revealing all the details of how it does it. That's all buried underneath. It looks so
yeah,
elegant. And imagine how maintainable this code's going to be, right? So once
yeah,
again, the back to that was appealing to the writer in me, right? Where I can write something that someone else can come and read later. Yes,
yeah.
I can tell the computer how to do stuff, but that's not the primary problem of software development. It's like
Mm,
you have to tell others how you told the computer to do stuff and make sure that they can change it to make the computer maybe do other stuff, right? Because like, and I used to tell people that I worked with, and maybe you got to hear it back in the day, I used to always encourage developers as they're working on something that imagine that the code that you're writing now is going to have to be maintained by someone 12 to 15 years from now, and that your
right.
code's going to survive. And like having that perspective of that there's longevity to the stuff that you write. And it's like, I don't know how many apps, and there was one initiative I had to get involved with where it was like converting a COBOL app to Java. It's like a 2-year project, and it's like, imagine like you had COBOL code that was written in like the 1980s or 1970s, and guess what? It's still running and
Right.
still doing stuff. And imagine that you have to go and read that and understand what it's doing, right? So thinking about that longevity, and similar, like we're that writing stuff down. So we are writing stuff down all the time in code, and we think it's buried away in some server room somewhere, being stored in some Git repo, and no one will ever look at it. No, eventually someone has to maybe go and look at it and do something with it. So
Yeah, absolutely. I think that's a good segue to start talking about your book then. You're producing something else that will live
it's
on
like
and
I've
people
got
will
I've
read.
got I got chapter 1 here. It's like
That's
early
amazing.
release now. Yeah, it's funny because I'm hoping um, to get the book out in like the next month or two.
Oh wow.
So all the content is developed. I'm basically in the editing stage and getting review feedback and whatnot. And it's funny because even my son is reading the book, and he's not a developer,
That's
but
amazing. Well,
he's in school studying journalism. So I'm like, use your English skills to tell me
yeah,
whether this is readable.
yeah.
But yeah.
Does it have a final name yet? What's it going to be called?
Yeah, so I think the title is going to stick. The subtitle I might change, but the title is going to be
Okay,
Eclipse Collections, categorically. Um,
nice.
and one of the things that has been, I would say, part of my story for the last 20 years. You might recall, and this is one of my blogs, and I've actually since written several other blogs about it. There's a thing I wrote 20 years ago called the Desktop Down Reference, which was like a single page of quotes of everything I know about software development. So most of the quotes, they're not my quotes, they're other people's quotes, and I'll attribute if I can wherever they came from. It's like, but stuff I heard over the years, and I wrote them down. And what I used to do is like tell people what I would, what these quotes mean to me. And I have since translated that into blogs where I have individual blogs, and so it's interesting. There's a correlation here. That desktop Don reference has initially had 7 categories of 3 quotes each. And it was very intentional that there were
Nice.
7 categories. Because in the first category, which is simplicity, there's a quote that says the human mind can comprehend 7 plus or
Gotcha.
minus 2 things at a
Okay.
time. So the magic number 7. It's like, then this is where like we get things like in the US, we get like the structure of phone numbers because we could remember
Yeah.
7 digits. Back when we didn't even use area codes, we would call people with just 7 digits. But so it's interesting is that that idea of categorizing things um, is what the book kind of focuses on. And it's categorizing the methods in Eclipse Collections. Because
Mhm.
Eclipse Collections is an enormous library.
Yeah.
And, if you have an interface, let's say, that has 208 methods on it, you'd be like, "Ugh, I can't look at this thing. I can't use it, right? So the book um, is intent on taking this large API and breaking it down into meaningful categories that developers can understand.
Yeah.
Like, you have methods that do counting. Maybe they do
Mhm.
testing things, right? Or they
Mhm.
do filtering or finding or transforming or grouping. And these categories help us take something very large and break it down into something that we can understand and comprehend. So the book focuses on how to take this large, amazing piece of software
Mhm.
and bring it to developers who, when they first experience it, may feel like, whoa, so much here. I'd rather stick with my for loops because I can understand those. So this is a way for, and there's this idea that I've written about for quite some time, which is, and it's about the 7 plus or minus 2, there's a concept of information chunking, which is about taking big things and breaking them down into smaller chunks where the information can be digested. And
Mhm.
you can dive into spaces that are interesting to you, but you don't start out with like, here's everything in your face.
Yeah.
And one of the things that I've absolutely fallen in love with over the last 7 years that I've been blogging. I use mind maps extensively in my blogs. I use them everywhere. And mind
Mhm.
maps are really a great way of doing information chunking visually. Because like you
Mhm.
have some root node and like then we have some leaves that come off of it and leaves off of those. And it's like you can understand what winds up being a maybe potentially huge space, but like it's broken down, individual compartments, right? So the book is intent on really passing everything that I've learned, for the last 20 years that will, help developers make all the work that's been done by not just me, because I am not
Yeah.
the person who did all the work in the closed sections. I get the ability to say I'm the creator. Yeah, I was there at the beginning, right? I contributed that first bit of code, but like there's folks like yourself that have made amazing contributions to the library. And what I'm very conscious of is like this book that I'm writing, it's not about me. It's about Eclipse Collections, which is the work of hundreds of contributors over a 20-year period, right? So, folks, may not know, like you created our initial set of, primitive collections in Eclipse Collections back when it was still, GS Collections. And these are some of the most popular, collections used by other open source libraries, and it's used by projects like Neo4j, which
Oh
is and
wow.
other large graph databases. They use the primitive collections because there's tremendous memory savings.
I did
And
not know
I'll be
that.
doing, and it's funny because it's not just the memory savings, it's also the expense of having to create these things because
Yeah.
Java doesn't give you list of int where the backing
No.
array is an int array, right? It's like list of integer, and I create these boxed objects, and like, my memory flies out the door very quickly, right? So, but it's once again, the book wants to, try and I actually do give tons of examples of primitive collections. And probably the largest section in the book is about how to move from object collections to primitive collections because you get this, and you'll know it probably, I don't know how much painful memories you have of it, but basically like, we use code generation for the primitive
Yeah.
collections, right?
Yeah.
And we're
Yeah.
using the
Of
string
course.
template library.
Mhm.
And it's because there's 8 primitive types and you don't want to write the same code 8 times,
No.
right? So you created templates, string template files to generate, you know, Boolean lists and, int lists and short lists and char lists
Yeah.
and long lists and double lists and float lists, right? So all 8 primitives. And the interesting thing is the library allows you to convert and transform between an object collection to a primitive collection and then back,
Mm.
right? So that winds up with like, we have to have transformations for each of these types, right? So I go through examples on all of them. So it's like, that winds up very detailed, but it really, I think, once again, is a credit to the work that yourself and so many others have done in the primitive collection space, that they get, front and center coverage in the book along with the object collections, right?
Right.
I'm really excited, when I get the book out there, the domain that I'm using, I'm very excited about. I'm not going to give a spoiler on it. You'll have to check out the book. But the book as well, like, in the first chapter, which I was just holding up, it's like it answers the question,
Why?
why Eclipse Collections? It's like, I get a collections library in the Java. Why do I want to download a third-party dependency and like, wind up having to deal with like upgrading versions and, have these extra jars and I'm just so it's explaining what it is that Eclipse Collections does and the things that I see, and have seen with the differences between what Java was providing and what Eclipse Collections give you. And what I had even actually, you get a bit of a history lesson in terms of Smalltalk as well. Like I could explain like where, some of these concepts and ideas
I'm
come
sure.
from. And really, there is this core concept that's missing from Java, which the whole book is kind of like, getting to, which is like Java doesn't have method categories.
Right.
And Smalltalk had them. And it really comes about that you have method categories when your APIs become large enough that information chunking is the only tool you have available to actually break things down. So it's like you can't just say like, oh, I have 10 methods now, let me create a new class.
Mm.
Well, maybe your class needs 20 methods, or maybe it needs 50 methods, or maybe it needs 208 methods, right? Well, hopefully most classes don't need that many, but collections happen to be in a space where like, guess what? When you have all this capability and behavior, you wind up with this much. But like information chunking becomes a key tool to allow you to turn something that is otherwise unintelligible into something that people can understand and comprehend. And we get code assist to help us, but like, sometimes the best grouping is not alphabetical.
Right. Right.
So it's
Absolutely.
like, okay, dot, and like, oh, I can start from A to Z, right? And then, scroll, right? It's like, what can help me get to the thing that I'm looking for as quick as possible. So
Right.
anyways, I don't know if you have more
Yeah.
questions or,
No, we're really excited about the book. And if you're watching this video after the book has released, I will link to the book as well so you can easily check it out. No, I mean, that was everything I had for you today, Don. Thank you
okay.
so much for being on the show.
Well, thank you so much for having me. And this was great. I really appreciate it. And it's great catching up with you sometime. And I really enjoy watching this podcast with others. So I'm looking forward to more episodes. And I would say, looking forward to more of your blogs as well. It's great to see you blogging. And once again, encouragement to everyone else out there. Hopefully you
Yeah.
find, that courage to write that first blog, and then you write the next 100 or so. I figure after 100, I started improving a bit. It took me 100 maybe to write anything. So,
It's, oh, I don't believe that, but it's inevitable, right? Of course, you improve once you start doing the thing.
yeah.
Yeah. All right. Thank you so much, Don,
All
and
right. Thank you.
good luck with the book.
Thank you so much.